Yeah, that's the topic. That's the name of the chapter. Wait, did I read it wrong? Oh no. Functions of... Oh no. 2 or more variables. Yeah. Okay, how this goes. I wonder how many students actually know that this is happening right now. Let us see. How much of a disaster is this gonna be? Hey Gath, how's it going? Wow. Wow, wow. Let me just do it. It's going? Oh. I don't know if you know the news, but I'm a permanent substitute teacher for a Calculus 3 course. And that's what's happening here. So let's see how badly I messed this up. I either run the course into the ground, or I, well, hold it steady, or I turn it, or make it good. I don't know. Let's see how it goes. Wow, Cosmic Conundra? Jeez! Incredible. Wow. Thank you. Thank you. That's, unnecessary, really. But yeah, we're about to start a Calc 3 class that I'm substituting. So yeah, you're welcome to be in the chat, but I'm not really talking to you if you're not in the course. Yo, FS Rooster, how's it going? Hey, Dark Me EQ8. Wow. Wow. Whew. Oh, where's my music? Spotify. Turn Spotify on. Then to go to the one soundtrack that I have permission to from. Awesome. Good. There it is. Oh, yeah. Protost? Yes. Yep, that's me. I think it will have 2 variables. Thanks, mate. Basically, that's how the course goes, I think. Yeah, sure, NC. You can be in the course. Bunch of losers, man. Bunch of losers. Usual losers in the chat. Jeez. Okay, let me just start earlier than I usually do. Wait for students to come on in. I have the clicking on. Let me address that. Stop that. Okay. Is it off? Is it off? I had to reinstall clicking. Thanks, Gath. Oh, thank you, Cosmic Conundra. Yeah. This class is about to start. Okay, got it, NC. Yeah, it doesn't, I think it's off again. BPS. I think it's off again. I tried it earlier. I tried Hue as well. This Hue thing? I tried this. Yeah, I don't know. It's that thing. Whatever. All right. That's right, Protost. That's right. They made one of the biggest mistakes ever. What? No. No one subscribe. No one subscribe at this point. Nobody should subscribe. Okay. Well, don't press subscribe. Yeah. But thank you. I'm not gonna ask you any questions about who you are, but do not subscribe, especially if you're a student. Oh my god. This one's gonna be trouble. Tired caster. Let me write that down. It must be a student. This one's gonna be trouble. Tired caster. Okay. Got it. Hey, Arbitree. Arbitree's teacher's pet today, guys. Everything Arbitree says is full of insight and perfect. Good job. No, I'm not juggling right before class. Hey, see? Okay. Abdul Rahman, aka Quintuple A. Grade A student from the summer. Welcome. Alright, you want some shungite? Okay, here's some shungite for you. Just for you, Quintuple A. So that your good fortune and effortfulness continues throughout your life. Okay, here we go. So, class, this is, I guess there's enough people for me to start. I'm assuming class is here. I am your new professor for, hey Carrot Cat, how's it going? For Calc 3. My name? I try to do a fixed number of things per lecture. And, for example, I haven't taught Tuesdays, Thursdays in a while, so I don't know my timing yet. So we'll figure that out soon here. I'll try to cover 5 things per lecture. And it's what I intend to do in that hour. I don't know if I can get everything every single time. I try my best. All right. So the first thing today is introductions. You probably want to know who I am, especially since we're going to spend the rest of the semester together in this Calc 3 class. So my name is Anand Patel. You can just call me Anand. In fact, that's how I prefer to be addressed. All right? In emails and so on. Okay? I'm a mathematician at OSU. And you can look at my website somewhere on the bottom of the screen somewhere. There's a link. If you want to know what kind of math I do. My main Wrong OSU protest. My main objective is to foster engagement. And that's why I do what I do. Like this. Alright, so you students have to talk to me on Discord if you'd like. Not to talk to these degenerates in chat. Spam questions in Discord. Email me things. Just talk to me. Especially since it's an online class. I want to know what's happening in my students' minds. Where is the confusion, etc. All right. So that's introductions. There's you can do either. VNV National, good to see you. Welcome. You've never used it before. I understand that. This is common sensation. What you just did there was perfect. Well executed sentence. I have never used Twitch before, so this is all new. Perfect. Do that. Just keep telling me what's going in your head. Perfect. Just spam it. Well done, right? Clap, everyone. Clap. Clap for Gaming Geek. Okay? Wonderful. Now do that, but like with a little bit more math content every now and then. Okay? Capital C, clap. Capital C. There you go. Okay. We have 2 emotes, I think. You can spam our emotes here. There's BM Hog for when I do excellent things. And BMP Focus. Yeah. All right. So it's great. We've got lots of great stuff happening. Okay, that's introductions. Done. Green. All right. Wow. Okay. Class, get on Discord as soon as possible. There's only like 5 of you, 6 of you that have entered. I can see it. And there's like, I don't know, 20 people in the class. So get on that. These VODs, the recordings will stay active for 2 weeks. I'll try to remember to upload it to the YouTube page so that you can watch it later, way later. I have to remember to do that at this point. Anything else I'm missing? I don't think so. Yes. Classroom dynamic. So outsiders, you guys know to respect the classroom dynamic. Never insult, anyone else in the chat. Target all your negative energy and insults towards me. And sometimes I'll get triggered, and that's part of how it goes here at in this classroom. Okay, so okay, great, and we'll try to develop some of the technology, test it out as we go here in this thing. Self-deprecation is encouraged and allowed. Yes, absolutely. Okay. So, class. Oh, hey, there you go. See, look, Zaraki joined the Discord. Welcome. Class, do more of that. Join the Discord. Go. Yes, oh, look at that. Look at that person. I'm not going to say their name because they used their actual name. Wow, fantastic. Great, welcome. Okay. So, that's sorry, Hangsmate, don't expose these things. Hi, Dutchy, welcome. Are you in the Discord? Hopefully you are, if you're a student. All right. So, we're gonna start chapter 14. Okay, just for now, let's just let the past be the past, because I don't know what was taught in the past, what was emphasized. I'm sort of in a weird situation too, okay? We're all in this together. But chapter 14 represents a fundamental new subject. Okay, that's great. It's actually great timing. Chapter 14 in the book represents a shift in topic. And I will be responsible to get you through chapter 14 and chapter 15. I don't know how much of 16 we'll actually be able to hit in this class because the class probably is delayed by some amount due to totally natural reasons. Okay? So I don't know what I can hit in the last 16 chapter that we're supposed to traditionally hit, but 14 and 15 I will get you through, I promise. Let's start. Okay, what is 14 about? I'm going to start lecture now. Okay, chapter 14 is called... Wait, what is it called? Functions. Functions of several variables. I don't know what it's called, but it's about functions. Okay? And so I'm going to tell you, I'm going to do a quick recap of functions of one variable because multivariable calculus makes a lot more sense when you keep comparing it with the one-dimensional or one variable case. All right? So I'm going to just do that recap real fast for you right here. Okay? We're going to do a recap. And then I'll tell you about functions of several variables. And then we'll try to understand how to visualize them. That's going to be really fun. And then, I don't know what this means. Try. I think it's this. I think they're the same, actually. 4 and 5 are the same this time. All right, let's go. 2. Functions of one variable. This is old school. Things like this. F of x. What does it mean? F of x meant that there was an input which was one number, and the whole thing was an output single number. Wow, incredible. Okay? I'll give you an example. For example, something fancy. Sine x. Incredible fun. Wow. Very complicated. Sine x. Yeah? Good. So we know what that is. That should be review. Hey, welcome to the Discord, that person. Okay. Now, pay attention. What happened then? Then they started asking questions about the functions. Right? They started saying like, oh, when is it increasing, decreasing? Started asking like, oh, when is it increasing? All these kinds of questions. Increasing. When is it maximized? Oh, you should maximize it. Maximized? Minimum? And all this, you learned all this calculus. And then there was like area under the curve. So on. Do you remember all that? Yeah. You remember all that? Okay. Good. That was Calc 1. It basically addressed these kinds of matters about a function of one variable. Now, I want to remind you that there's a way to visualize such a function. Now, visualizing it. Now, I'm going to do it in slow motion. Just pay attention to the steps. First, what you did, you created a new variable. Called it y. Usually it's y. Typically. Yeah, carrot cat, yes. Here's some shungite for you. Right here. Carrot cat. Former student. Maybe even in this same subject, I think it was. Create new variable y. And then you write down this thing. You write down that expression, y equals f of x, and then finally you draw something. you draw something in R2. Notice to visualize a function of one variable, you drew something in two-dimensional space, R2. And the two axes in this R2 are the x-axis, or the input axis, and the output axis, which was a y-axis. And I purchased these stickers from this here Notability app. Look at that axis. Wow, there it is, perfect. Now I can just say the y, x. And this equation traces out a locus. All the x's and y's that satisfy this equation form what's called the graph of the function. Something like this. Okay. I tried. Yeah, this was y equals sine of x. Notice that this yellow thing is the graph of the function sine x. So the function is just what it was. Input, output, thingy, box. You put stuff in, it spits stuff out. Hey, welcome to the Discord, person. Right? To visualize it, you draw the graph of that function. The graph is a picture that helps you understand the function. And when it's really tall, it means the outputs are big. And when it's really down, it means the outputs are negative, really small, negative or something. Right? So the graph is a visualizer for the function. Yes, yes. Write that down. Write that down, everybody. Okay, why did I do this so slowly and painfully? Because what we're now gonna do is expand the notion of what kinds of functions we will study. We will study functions that have more than one variable as input. That's number 3. Topic number 3. Yo, Kappa, how's it going? How's it going? All right, I'm teaching here, folks. Crow, you know, whatever. All right. Functions of several variables. Write this down in your note cards. Oh, wait, before we go on, let's test some technology. Class, 32 viewers, that means my class is here. Basically all of them, that means. Okay, welcome class. We're gonna test some technology, all right? When I tell you, you're gonna click the screen. Like the screen. You're gonna click it. Okay? We're gonna do a sample question. This is how I test whether the class is smart or not. All right, here's our question. This is an accurate... Oh, wait, hold on. I need to start the clicking thing. I gotta start the clicking thing. Restart. Here we go. Ready? Clicking software is enabled. This is an accurate sketch of the graph y equals sine x plus 2. Just click on the circle that you think is right and just keep clicking it. Just like at a uniform rate. Everybody click. There's only 12 of you clicking. I can see it, class. Don't think you're not going to get away with this. Only 12 people clicking? 12. Not with your finger. You don't touch it. No, with your mouse. Don't like physically touch the screen. Okay, 12 users. Wow, there seems to be a little bit of conflict here. Good. 13 people have clicked so far. The class has what, 20 people in it, so 13 is less than 20. Are you telling me that class doesn't show up to class? Huh, that's probably what you're telling me. Okay, good. So, 13 people have clicked a total of 490 times. So I'm going to stop this at this point. And, all right? And based on the results, it seems like 2/3 believe that this is an accurate sketch of this graph. Okay? Wrong. That's wrong. This graph has some serious flaws, folks. Very, very flawed graph. Now you might think, wow, it's shifted up to. It's shifted up to. Yes, good. But it's sin x starts with positive slope. It's complete. It's like ass backwards. Look. Where's sine? I have a sticker for sine x. Do I? No, I do not. I do not. I've got a sticker for this. All right, you got it incorrect. I bought these stickers, so I'm going to use them. Okay, fantastic. All right, incorrect. It should be kind of other way. But the axes don't say which way is positive x and which. This is a funny person. That's really funny that you say that. Okay. Anyway, we're just testing the technology here, folks. Let's go back. Let's move on now. Functions of several variables. So good start, class. Really good. Really made me proud. Good job. Functions of several variables. It's going to be a nightmare. What does it mean? It means you have a function which has several numbers as its output. Input. Look, and how do you do it? You just sort of go like this. Or G of UVW. Or F of STR. T of X1, X2, X3, X4, X5. Write your own on your piece of paper right now. Incredible. It's what it is. Now, what does it mean? It means that it's a thing that outputs a single number once you've placed all of these numbers in. Very easy concept. Very simple concept. Functions of several variables are ubiquitous in this world. In fact, it's very rare that you're in such a simple situation where some output depends only on a single parameter. That's such a simplified situation if you think about it. Right? For example, consider the following function. E equals a temperature function of the universe. Think about that. It is a function of x, y, and z. There's going to be some nerds in the chat that say, what about time? T. I don't care about you. Whatever. Just at a location x, y, z. What is the temperature there? This is the function. This is the temperature. At location x, y, z. Totally natural, right? Totally natural. The beta function. I expect Thanks, mate. Yeah, that's good. That's a good function. Okay. Yeah. See, they're all over the place. Go ahead and think of another one. Look. Here's one. Here's one. E. Okay? E of xy is. So what it is the following. I didn't tell you about this, but there's a state park. There's a state park. What's the name of a state park near here? Anyone have a... What's the name of a state park around these parts? Stillwater? Okay, Stillwater National Park. Is that a thing? All right, Stillwater National Park. Okay. Stillwater National Park has an elevation function. What it is the following. E of xy is the elevation of the national park, and you've devised a way of putting a grid from the air on the park, like a map. Think of a map. At the map location x comma y. Yeah, you think of the xy axis as a map. Is this making sense? Very simple. But this example, you want to keep in mind all the time, in my opinion. All right, so here's a map, yeah? You've opened it up. At different points on the map, the actual national park is like a mountain there, or a valley. Yeah? Think of that kind of data. It's captured by a function of two variables, your x and y location when viewed on the map. Okay, elevation functions are very, very useful in low dimensions for visualization. All right? In a math class, you will often see functions given by actual formulas. So in math class, where things have like simple, just explicit formulas, I'll give you some math examples from math class. X squared plus y squared, classic. Okay. Here's another one. G of xy, square root of x squared plus y squared. It is the distance from origin function, if you'd like. All right, here's one. T of xyz is sine of, write this down, cube root of the x squared plus y squared minus, of course, z4. Now, I forgot to tell you, then you divide by natural log of x to the 1/3 plus pi. Sorry, this is all divided by y, of course. You see, you can do all sorts of shit. You just don't get scared of it. It is a function of several variables. It has problems. It has a bad domain. It has issues. The concept of domain, continuity, sharp corners like differentiability. These will all be taken up in this week, basically. Functions can have problems. And then there will be the good ones that we study and the bad ones that we just throw away and don't think about very much. All right, we'll talk about these issues, especially continuity and differentiability as the next topics. Thanks, mate. Exactly. Thank you for reminding me of this. Okay? Awesome. All right. So, what the heck do you do when you have a function of several variables? Now you know what it is. What do you do? The first thing you try to do in this class is sometimes try to visualize it. Wow. Wow. A+. Okay, I'm just grading myself as I go. How to visualize this? How to visualize a function. Where are we in the analogy? Here. This graph thingy. Can we do that for functions of several variables? The answer is yes. One time we can do it. How to think about a function of several variables. Gaming Geek, the last one looks terrifying. It'll be on the final. Don't worry. Just for you. Yeah, I'll write a separate final for you. And that last function will be on it. Okay. So how to think about a function of several variables. There's actually two ways I want to emphasize. Two ways. The first way is to try to try to draw the graph. Graph it. Now, this is going to work. This is going to work basically only in one situation. Okay? This is going to work when you have a function of two variables. Or, of course, Calc 1, function of one variable. That's old news. This is going to work when you have a function of two variables. For example, let's just take our simplest, innocent little function, x squared plus y squared. Okay? Now, how does graphing work? Introduce a new variable that represents the outputs. I'm just going through the slow-mo thing. The new variable has to not be any of the ones you've already chosen. New. And we typically use z, right? You guys have been playing around in x, y, z space up until now in this semester. Okay? You place that axis perpendicular to all the other variable axes, the input variable axes. Conveniently, we have the ability to do that in our mind's imagination. That's the third eye of our imagination. And so I purchased a sticker that allows me to do that. Look at this. Look at that sticker. There you go. X, Y. And then this is... And then the graph is the following locus. Notice the difference between the function, conceptually, and the graph of the function. Equals the set of triples, x, y, z, obeying elevation equals output of the function there. What do graphs of functions look like as a cartoon? They look like this. Hills. And maybe valleys. Now I've drawn some dotted lines and stuff to give you some three-dimensionality. Locust. Did I say locust? Yeah, I meant to say it. I don't make mistakes. Right? Okay, and how do you sort of think about points on this thing? You think about the inputs as happening on the ground. The ground is the input space, XY plane. And the output is thought of as elevation. Z coordinate. F of xy. There's like a positive number here for this xy. Could be a negative number elsewhere. Okay? Do I need special glasses to see the surface? Soon. Soon we will. Okay. It's a good drawing? Thank you. Yeah. Okay. Notice that when I tried to visualize here, I used some like 3D aids, visual aids. You see, first, for example, I gave you a sort of a feeling of three-dimensionality by slicing this surface using a level plane, a plane that's flat along the z is constant plane. That's called taking a level set of such a function. It's this sideways circular thing. Let me draw a couple more level sets for you. Here's one. It's at this elevation. Z equals 10. Is that 10? I don't care. Whatever it is, constant. Take it, you slice it. And you can sort of give a artistic rendering of it by its level sets. It's not just an artistic device. It's a way of kind of getting your brain telling the sort of MRI scan of the thing from one axis perspective. I've also drawn a slice of the surface by holding y constant at something, 2 or something, right here. It's just ways of trying to slice the shape so that it makes sense in your mind's eye. A lot of this will involve imagination, flexing that that visual cortex right here in the cerebral gyrus.
Yes, science.
Okay, write that down. Okay, and of course, there's also you can slice with x, but for functions, it's often very fruitful to try to imagine the slices of the thing with z equals constant level sets, level curves. Okay, good. So this yellow hill represents the function. You can read off what the function is doing by asking what the hill looks like. Cerebral gyrus. Yes, it will be on the final. Yes. Okay? Good. Does the function increase here? Does it decrease? What the hell does that even mean anymore? Which way is the function going? Tangent line. What is that in this context? Can I maximize this function over a certain thing? How do you do that? What is the volume under the hill instead of the area under the curve? How do you do that? That's basically what I'm going to teach you for the rest of the semester. How to take Calc 1 and port it over to higher dimensions. Okay, specifically 2 we'll focus on. Okay, great. So that's one way of visualizing a 2-variable function. Okay. So the second way I want to tell you about visualizing a function. Second way. This way is not very often taught explicitly. Maybe it's because students don't like it, but I'm going to teach you anyway. Another way of thinking about a function is actually more naive. What you do is you split your brain down the fusiform nexus, of course, and you use the left side of your brain to draw the input space. For example, we have an input space of R2, X and Y. I have a sticker for that. I bought this specifically for the course. You see this? X and Y. Let's do an example of f of x, y. And then you draw a picture of an axis that represents the output numbers. Wow, Shaquille Oatmeal. Thank you. Thank you for the support. Yeah. All right. Yes, you split your brain down the middle. Right hemisphere, output space. That's just a single axis. Do I have a sticker for that? No. Let's see. Okay, well, I'll just have to make my own. Output axis. And okay, this doesn't feel as visually appealing as the other ones. However, just have it in your mind ready sometimes. Sometimes it's useful to think in these terms. Okay, and what you think about is you take your mouse and you start clicking spots in the input. And every time you click or point to something, you'll register a red dot on this thermometer. And as you move the input around, the red dot's going to go up and down. What is this music? Yeah, it's just that visual. Oh, moving the red dot, moving the input dot around in the XY input space, and just seeing this red dot, how it goes up and down. And just imagining that, like, what could happen, all the possibilities that could happen as I wiggle and jiggle that input point. Maybe in certain directions, the red dot goes down if I start moving. And maybe in other directions, it starts to go up. And maybe all of this together is what the increasing and decreasing nature of the function should mean. This point of view is useful just to always have ready to bust out, okay? Especially when you have high dimensional input spaces, more than 2. Okay? Just a way of thinking. All right. Now, my students, before I was a substitute teacher, right? No one wants to be a substitute teacher. Just remember in school, the substitute just completely was just, no one respected them. But back when I had mad respect, my students, they felt comfortable talking to me, and they'd be like, they would reveal things like, I can't imagine things like in R3, the graph of this function, I just can't do it. Like you're a genius, professor, and you were born with the ability to just imagine using the cerebral central third eye just perfectly things. You didn't have to practice. You didn't spend lots and lots of time like trying to sketch using level curves, various surfaces, and get a sense. No, you were born better than me. I struggle much more. Have you tried like practice problems? No, I haven't. Oh, okay, fine. Yeah, but I uniquely, I struggle. It doesn't snap right away in 1 week. It doesn't suddenly spark. Can you please just tell us how you think? And I've been trying to tell them, it's a practice. You keep sketching various things, look at simple examples and learn from them, and read the book, maybe. But that just, it's almost like they don't want to hear that answer. So here, we've developed some technology, class. Finally. We've finally developed neuroimaging technology. We, meaning my younger brother, for free, just in his spare time, made some technology. We're gonna go test it out now. Now you gotta secure the neuroimaging fMRI scanner. And we're gonna go look at some graphs of functions, just for fun. Okay? Graphs of 2 variable functions, so you get a sense of what the kinds of objects we're dealing with here. All right? Let's see if I can execute this. Can I execute this? Just a second. Just a second. I'll try to use this technology more and more throughout the semester. Hold on. Just a second. All right. Now, class, don't worry. I'm still here. I'm still right here. You're still at the same place that you're sitting, watching. Don't worry, we haven't moved classrooms. See, you can see me drawing? Everyone can see this? I'm still here. Okay? So we've got our chalkboard here. You can actually enter this third eye. We're in the third eye now. We're in the seat of my consciousness. This is where all of my visualization happens. This is what it's like to be me, in short. Okay? All right. Come join. Thank you, Crow, Arbitrary. You can sleep here if you'd like. Everybody come. You just press exclamation point, attend, like everyone else is doing. And you can just enter class. Just feel free. This is totally secure place. No one can hack it. All right, we're going to go over to Calc 3 over there. Right? Oh, yes. Welcome, everybody. Welcome. Let's go over to Calc 3 because that's what... Can you get out of my way? Okay, Calc 3. Let's go. Don't worry, you're still here somehow. And now we're going to graph some things. At least I'm going to test it out to see if it works. Let's graph that x squared plus y squared function from before. Incredible. X squared. Notice how I'm typing it in. Upper right corner. All right, add this graph. There it is. Let's go look at it. Now, the x and y axes are like as follows, okay? The y-axis points directly to the Shungite pyramid off in the distance. That's how we'll remember. And the red axis is the x-axis. Goes this way. Okay? Great. So here's our paraboloid. Can we look inside? Yes, we can. We can go inside it. And we can look downwards. I'm looking downwards right now. I can also look straight upwards. Now, okay, whatever. All right, so this is z equals x squared plus y squared. You see that up there? Z equals x squared plus y squared. Standard paraboloid. All right, you want another graph? We can do z equals x squared minus y squared. Make sure you write all this down in your note card. There you go. Okay. This is cool. It's like a X-Wing TIE fighter type thing. Okay? This is a hyperboloid or something. You guys learned that already. Hey, this point here is interesting. It's kind of the function's increasing that way, but it kind of decreases when you go forward and backwards. Let me see if I can see the side here. Yeah, see here? Oh, it's kind of decreasing down here, but increasing in a different way. Hyperbolic paraboloid. Thank you, Not Prof. Not Prof is a real prof, folks. Shout out to Not Prof. I can't do it from here. I'm deep in meditation. Okay? Awesome. So this is what a x squared minus y squared function looks like. And maybe I should draw it with the axes in the right position. Y positive is that way towards the Shungite, and X is this way. Okay? Beautiful, beautiful surface. Let's look at another surface, just for fun, so that you understand that functions of several variables are very cool. Sine of, check this out. Check out this function. X squared plus y squared, all square rooted. Also known as radial distance to the origin. You guys learned cylindrical coordinates. This brackets might not work. Let me just put that there. Add this graph. Update selected. Let me do something to this graph. Let me increase the range. There you go. Get that resolution up. Nice. Okay, check out this graph. Graphs can be all sorts of cool shapes. Graphs of functions. By the way, this graph makes total sense if you think about what I've written here. X squared plus y squared all raised to the 1/2 power is also known as r, the radius away from the origin. And so you're looking at sine of r. And that means this function's going to be rotationally invariant. It doesn't matter. What matters is your radial distance away from the origin. And what you're going to see is the graph of sine emanating outwards. So it makes a lot of sense. Carrot Cat has a request. Every request is $5 minimum. He didn't know that, but so we'll let it slide this time. But yes, sure. Let's do Carrot Cat's function. Capital K of xy, known as sine of xy. Let's do a separate graph off to the side. This is sine of xy. X plus y. Sorry. Right here. Carrot Cat's function. Okay? Awesome. Yes, also known as the sun chip. Correct. Okay. So, graphs of two variable functions. They have these nice surface depictions, and we will be studying basically what we did in one variable calculus, but kind of for these kinds of two variable graphs instead. That's the bulk of what we're going to do in this class. Okay, let me get back to my screen and let me see what we had in what I was supposed to do. How to visualize. I showed you the concept of graphing it. Okay? All right. But there's one final way that I want to talk about in this lecture, which I still have. Let me see what time it is. Yeah, I still have a significant amount of time I can spend. Okay, there's one more visualization tool, and it's called a contour plot. Okay, so I'm going to do this one more time, like a third visualization tool. Okay. Now, do you guys want to go back to hello class? Oh wow, made it to the second row. This never happens. Just watch. As the semester goes, it'll be like 3 people here. Okay. Here's your attention. Each of you. Welcome. Okay. Isn't there an exclamation mark fire? Does that work or no? Is it working? Exclamation mark just fire. Ah, there we go. So when something makes sense to you, you can go ahead and do that. Okay. All right. So let's go back to, let me come out of meditation. And make sure I was... Okay, so take off the neuroimaging software. Now I want to discuss something this time. Another way of visualizing a function of 2 variables specifically. Contour plot. So, what the heck is a contour plot? It's a very simple thing, totally intuitive. If someone stuck it in your face, you'd know what to do with it. Okay? It's like reading a map. Like reading a map of a national park. I'm going to draw a contour map of a function. Okay, let's draw. I'm just gonna make one up live on live TV. Okay, so here's our axes. Incredible. Okay, I'm gonna make up a contour map. Topographical map. Yes, good job. How do you spell that? Topographical map. Yeah, I'm going to draw one. All right. There it is. Okay, that's the best I could do. That's the best I could do. Okay, there's one. Okay, let me do another one real fast. I think I can do a better one. Let me do a better one. That one was kind of boring. Let me do a better one. You can make your own, by the way. You should do it right now. Okay, now. You actually can't glean any information from this garbage right now. Next to these little curves, I'm going to draw some numbers. Okay? This is 30, 40. You guys see that? There we go. And what these numbers mean is elevation or output of function. So how do you read this thing? What this thing is trying to tell you, it's trying to give you a sense of a particular function. This function's contour plot is being represented here. And what this is saying is, on these xy points for this curve, the output of the function is at 10. So the function is outputting 10 for all the points on this curve. X and y input points. X comma y's are inputs for my f of xy function. Okay? Exactly, not prof, exactly. So what is this function? What does it look like in the other way of thinking about a function of two variables? The hill. Well, this is literally like a hill. It's actually, you can start seeing things like, look, each of these elevation markers is at increments of 10 miles. Whatever. Okay? And so you start to get a sense, like, look at that. When the lines are further apart, between 10 miles difference elevation, that's like a gradual part of the hill. Probably nice and easy. Nice, easy slope. But I mean, look at this part, for example. Wow. That feels steeper. And what you're looking at is the gap between constant increment elevation. So I'm choosing 10 as my sort of resolution of this contour plot. Level sets jumping by increments of 10. This is the level set, the level curve for z equals 10, or f of xy equals 10. This is the level curve for f of xy equals 20, etc. And the closeness of the curves gives you a feeling of how bad or how dangerous that location is. Okay? Oh, awesome, Fembox fan. Awesome. All right? In short, class, bringing this all together, when I drew these like slices of this hill, it's like I separated out the contour curves and I placed them at the elevation that they should be. these sort of slices. That's how they all fit together. It's like you're looking at the surface from above, but you kind of know which layer is at which elevation. That's what you're doing when you think of a contour plot of a two-variable function. Easy thing. Okay, so what we're gonna do is look at some contour plots, right? Okay. Okay. So let's. Okay. Okay. This one, real fast. We'll go back into meditation in a second. But this one. Now, careful. Careful. Look carefully. This is negative 10, 20. No. 0, 10, 20, 30, 40. Look carefully. Come on. Negative. What? Look at those elevations that I put, or the contour amounts. Now, what does this look like in your mind? Can you imagine this? Can you imagine this one? The actual 3D shape. It's a game. It's fun. Can you imagine this surface? The graph of this function in R3 from this contour plot. What does it look like? Anything descriptive you can say? Procrastination. Okay. This was a bad example. Okay. Why did I even? All right. Forget this one. Let's just go. Let's go into the third eye. Okay. What was I thinking with this one? I can't even. Well, I don't know what I expected from this class. I mean, this class, dude. All right. Yo, what's happening to my screen? Hold on, I gotta adjust my screen. Okay, there you go. All right. Okay, yeah, just forget this one. Forget this. Here, there we go. Okay. All right. Or just everything there. We're gonna look at some contour maps. Ready? Get in here. Are we in Calc? No, where are we? Okay, we need to go to Calc 3. Okay, ready? Oh, hey, not prof. Okay. Let's test out the contour map capabilities. Let's look at the contour map of our friend, the Paraboloid. Where did it go? Where is it? Oh, there it is. Can't miss it. Okay. Now, if I were to press the button C, you see? This is an example of a contour plot. Now, the way you read this and the way you read the ones in the book is the darker the color, typically it means you're descending in the Z direction, and the brighter the color, it means you're increasing in elevation. Okay? And notice that this contour plot has these like lines of these contours. We should call them contours. Various level sets at a fixed increment. Okay? Notice they kind of get wider towards the middle. And that's reflecting the kind of curviness of the bowl, the curvatureness of this paraboloid. Notice that there's thinner out here, the sort of level sets that have the same, some particular, let's say 10 increment. They get kind of closer together, getting steeper out here, shallower down here, until it's like very shallow down at the bottom, at the origin, the bottom of the bowl. Okay? We can change the color if you want. Good. Level set. This is a contour plot. I can try to change the contour offset too. This is like cataloging different elevation level sets, like increments of 5 feet rather than 10 feet. It's like a resolution for the thing. All right, good. Awesome. Did that make sense? All right, let's look at another contour plot, just for fun. Ready? X squared minus y squared. Hyperboloid of one sheet or something. Pringle. That's what it is. Let's check out its levels. Its level curves or its contour plot. Just for fun. Wow, check this out. Darker colors, descending, getting smaller. Brighter colors, outputs getting higher. Mountains. So there's a mountain that way. There's a mountain that way. But then there's a valley that way. And a valley downwards. It goes down. This is a point where the function is like neither you can say it's like totally increasing, nor can you say it's decreasing. It's kind of split. Some directions you'll go down. Other directions in this national park you'll go up. And you go steeper and steeper here. You see? These are closer together. Then it gets further apart, further, until it like really bottoms out right here. And then, etc. That's how you read a goddamn contour plot. It's intuitive. All right. Awesome. So you'll see a bunch of homework problems that try to match a contour plot with a 3D model. And it's just a game of imagination. All right? You'll see questions like, hey, if you're over here and you move that way, are you going to be going uphill or downhill? Those kinds of questions. Very easy to answer just when you understand what the heck this contour plot is doing. Okay? The contour plot will be very, very useful when we learn how to optimize, do optimization problems in Calc 3. So that's why we're bringing it up right now. It's a useful way to think about a two-variable function. Okay, great. So that's what I had to cover for today. I want to come back to reality just for a second. Okay, and I want to see what was my fifth thing that I want to talk about real fast. Remind myself. Try. That's right. Try. Okay. Yes. I'm not touching, as much as possible, I am not touching the course infrastructure. I don't want to make sweeping changes because it's too much. Yeah. I'm going to just try to sneak in and continue the thing. All right? Now, if students have a strong dislike and want additional problems, that's a separate matter. I'm happy to add things to the course. I'm not going to subtract things to the extent that that's possible. Okay? Good. All right. And discuss those things on Discord with me. All right? Good. No, but not prof. It's I'm on a particular committee this year, and I get to see student evaluations of professors. And it's actually not completely infrequent. There are students, like the good ones, who give constructive criticism like, there weren't enough problems like this. You gave a lot of problems like that, but there weren't enough like this. So, sometimes students want more practice. Speaking of which, students, I have changed the WebAssign template to allow you to practice a similar problem. I think I've made that change. If that's not the case, please tell me as soon as possible. One more thing. It seems like Sundays is when your homeworks are due. So I've just been keeping that. I don't know if that's true. But no problem. Do the homework together. Make your own Chegg. Make your own Khan Academy. Do it in the Discord in front of me. I want you to talk to each other for the homework. I want to see that. So do that in Homegrown Chegg. There's a channel for it. All right? Ask each other questions. Good. Okay. Next, homework is still, it looks like it's Sundays. Tell me if I'm wrong, especially on Discord. Tell me these things, class-related stuff, tell me on Discord. Seems like it was Sundays. I'm going to continue that. This Sunday, there are 2 homeworks, 14.1 and 14.2. I'm completely on track. Thursday will be 14.2, limits and continuity. Okay, it'll be a lighter topic than this first conceptual one. There's no chat history in the Discord? I messed something up. I just messed something up. I will fix that. Oh, Carrot Cat. You don't have to, Carrot Cat, but yeah, there are some old friends in that Discord. Calculus 3 students from the summer of hell, COVID summer to 2020. They're in there. They were kind of the guinea pigs and made this whole thing flourished because of them. That was the epic summer. Yeah, imagine Calc 3 in the summer. It's really fast paced. Okay. Yeah, you will see it going forward. And I think I prefer that because you don't want to see what those previous degenerates said in the chat beforehand. You know, it wasn't very sophisticated stuff, VNV, so don't worry. Or the SUNY Calc 3 speedrun. I don't understand that course at all. I don't get what a person gets out of that course. Like, I would fail that course if I was just honest with where I was, like, workload-wise. Almost like you gotta already know it. Anyway. Oh, so the 5th thing was try. What do I mean by try, class? I want you to take a look at these contour plots, which previous students don't reveal anything about whether you recognize these from your class when you took it or not. But whatever. I freshly made these just for you. Okay. No, I made these. Okay, look, this is a contour plot for this here function. Now, so write this down in your note cards, students. Just real fast. This is the contour plot of this function. Understand the difference. I want you to try to understand the difference. Believe it, like, yeah, yes, right, of course. See if you can get a sense of. Explain it to yourself. We've seen this one, the hyperboloid one-sheet Pringle saddle. I made these. I made these. A linear function. A number times x and a number times y and then a number. Check that out. Contour plot. Makes sense or no? Caret cat's function. Right here. Sun chip. We'll get back to this one Thursday. What is that? What is that function? What's going on at the origin? What is that? These last two are the topic of Thursday. All right, next topic. But I want you to try to match, at least convince yourself. This one looks pretty accurate. This one, yeah, linear functions look pretty nice. There's kind of a constancy behavior in the contour plot. Like a constant slopiness. Weird curvy thing. Not linear. Not a linear thing. Curvy. Roundy. Not linear. Round, curvy, not linear. Just get a vague sense, a comfort level with the contour plot versus the actual 3D shape. All right, so that's the end of lecture. Sometimes I'll go over, sometimes I'll, no. Basically, I'll go over if I ever go mess up the timing. That's okay, class. If I go over, don't worry. Go home or wherever you are. Stay home. And you can see the VOD afterwards. It'll just show up on the channel. And I'll try to make sure I port it over to YouTube every single time. I just have to remember to do that. I'm jumping in mid-semester, so I'm going to forget a bunch of things. Okay, so I'll see you all on Thursday. Now I'm just going to end stream by doing some credits is what I usually do. All right, credits. And I'll look at chat and see what kind of degenerate comments you made. Try to do math comments every now and then, not just like your usual stuff. Bye gaming. See you. Have a good day. Bye Carrot Cat. See you. All right. All right. It's good to meet you, class. I hope you keep coming and engaging. It's only fun when you engage. One more thing. If the class is comfortable with this, I will start voice calling you on the Discord. You see there are some things called voice channels. You go into it, I join you, and I will call you. And I will just ask you questions about the material. There are some brave students that actually participate, but there's no pressure with this class. Only if you want. I'll try that on Thursday. We'll practice calling on the Discord. You're gonna need a mic if you want to talk to me. All right, so I'll call, we'll try practicing that kind of engagement. All right. Okay. Contour plots of the Roman surface. What would you try? You should try it. What would it be like? Well, the double curve slicer will be singular. You should try it. I can't. Yes, Carrot Cat. You remember Phobo? Yes, we need an ambassador. That's right. A general. Because it's called generals. General voice channel. So I call them the generals of Discord. Alright. Hey, credits. Who's here? Not Prof. Welcome. Real Prof, people. We have some educated people here. Don't let it deceive you. These are not completely random people. We've got our mods. AC. Smash Time was here. Saying just random garbage like usual. But always an old friend of mine. Hey, Toaster. Haven't seen you in a while. Hey, Gath was here actually. Gotta get the mods out. Gath. Chemistry professor. You want to see an online class done right? Class, go see Gath. Maybe I shouldn't have told you early in the semester. Okay, whatever. Then we got BPS. Younger brother, who made all this garbage. Can you believe this? Just from scratch. And a Unity engine, something called that. I don't know what that is. All right, next, Toaster. Okay, who else is here? Strawberry, I see you. All my new students. Thanks for showing up. Showing up is a huge deal, especially in an online class. Thanks for showing up. Who else is here? Who else made the stream fun? Crow. Okay, Crow is, you know. Crow is Crow. Procrastination. Welcome, welcome, welcome. VIP Carrot Cat, no doubt. These are my old students. Quintuple A. Quintuple A. AKA Abdul Rahman. Another excellent student from the summer of Calc 3. Okay. Fine, Kappa. Kappa! Kappa is a beloved new mod. FS Rooster wants their dopamine hit at the end. Classic. Classic dopamine junkie. Notice, class, if you go and look at FS Rooster's logs, they only speak at the credits. What do you think that means about them? About their character? I don't know, I'm just asking the questions. I don't know. Femvox, Arbitrary. Hey, Arbitrary's here. And Femvox. Mods were out in full force today. Good job. Lot of bad stuff in the chat. I saw it. A lot of wrong answers too. That sin x plus 2 test question just to test the technology. Did you guys see that? Sine goes up in the beginning. Doesn't go down. Alright, next. Who was this? Fembox. Wow, not prof. That's skillful. Alright. Okay, and soon I will start saying my students' names one at a time. Once I get a sense of which people are actually my students and which ones are, you know, the other weirdos in the chat. But I think I know. I think Tired Caster might be. VNV. Iskin, I think. Gaming Geek, I believe, is another one. Yeah. Maybe El Shante? 11? Maybe? Maybe Jumble? Okay. And the last thing, hey, Root, thanks for subscribing. Why did you do that? That's terrible. Okay. Last thing, people requested some stuff with their channel points. So I'll do that. And then we'll call it. We'll call it a day. Because, folks, I now have immense amount of teaching responsibilities, suddenly. I've got Galois theory, commutative algebra. Just think about the diversity of the topics. And think about what it does to the fusiform gyrex in the prefrontal lobe.
Science!
Galois theory, commutative algebra. This class, intersection theory, starts Wednesday, tomorrow at 6 p.m. So I need to go, really. I gotta go. But yeah, I'm gonna humor your request, Crow, for a recorder. I'll do that. And then I think I needed to juggle. I think I needed to juggle. So for AC, I think. And that's it. That's it. Okay, for strawberry, fine. All in one. Okay, here's the recorder. Maybe I should just practice things that I once knew, which might be useful in this Calc 3 class. I knew how to play Jeopardy, the theme song. Let's see if I still know it. Let me play a scale real fast. Good. Great. And then I do the key change. Boom, boom. Wonderful. I still got it in me. So I'll be able to do that in the Calculus 3 class when I do questions with clickers. That'll be good. Juggle. All right. Okay, so I got to juggle. Here's your garbage streamer music. Okay. Okay, ready? All right. Class, what did we learn today? We learned how to visualize a function of several variables. In particular, two variables. Two input variables, one output variable, z. Basically, the graph is some hill type thing. Or you can slice it and dice it and think of it as a contour plot. One mode of thinking is useful in one circumstance. The other is useful in other situations. Why not learn both of them? Yeah? Okay. Good. So I think that's good. Let's okay. Ready? Let's go. Let's go. BMP might have neglected his recorder practice a little bit. Yes, that's true. I have not been playing very much. How can I visualize a curvature that has vanishing divergence? I have no idea. Good question. Are you gonna send us somewhere? Do you guys want to go somewhere? Where do you want to go? Is there somewhere that... Is there a friend of the stream that's on? I hate doing this. Okay, raid channel. Okay. Hey, Dr. Young's lab's on? Definitely. Dr. Young's lab. Hey, Dr. Young's lab? Physical chemistry professor. Does excellent lectures. Almost as good as mine. Okay, people? Go spread the love to Dr. Young's lab. Alright? How do I do contours? Oh, you're thinking about the Roman surface? Yeah, well, let's think about it. Yeah, I'm curious to see what happens. Okay, Dr. Young's lab though. Fantastic. Let's go. I click this, and then I click Start Raid. Wow, he's doing some real science. Amazing. Let's go check it out. Respectfully. Don't derail his whole thing.